Welcome to saitechinfo channel, my dear students. In this tutorial, I will be explaining about electric current. Generally, charge is nothing but the integral multiples of electronic charge. Here, Q is equal to NE. Q is the net charge, N is the integer, E is the charge of electron, that is given by 1.6 into 10 power minus 19 coulomb. That is the charge possessed by one electron. Q is also equal to IT because it has been derived from this equation. I is equal to Q divided by T. So the current is nothing but rate of flow of charges. So, by comparing the LHS, we can equate the RHS. Therefore, IT is equal to NE and I is equal to NE by T. Let us consider the water flow. When the gravitational level of two positions, that is two levels, remains same, there is no flow of water. But when there is a difference in the gravitational level, that is at one point the tube is at higher position and the other end of the tube is at lower position, means there is a difference in gravitational level. Therefore, there is a flow of water. Similarly, between two positions of V1 and V2, or you can call it AB, the potentials remain same, means there is no flow of current. But there is flow of current when there is difference in potential. Here V1 at higher potential, V2 at lower potential. So the current flows from higher potential to lower potential. Now let us discuss about average current. Average current is nothing but the delta Q divided by delta T. I, that is current, is equal to limit with the delta T approaching 0. It means the change of charge in the shortest interval of time, that is delta Q by delta T. It can be called the instantaneous rate of flow of charge, that is dQ by dt, that is current I. Now let us work out the unit for I. The unit of I is equal to ampere and Q coulomb divided by second. So coulomb per second, 1 coulomb per second is equal to 1 ampere. We can work out a problem based on this. Let us consider a charge 120 coulomb and this much charge is passed for 1 minute through a conductor. So you can conveniently convert into second. So 60 seconds. So what is the current? We know the formula I is equal to Q by T. So substitute Q and T so that you will be able to get 2 ampere. Now let us talk about the direction of current. Look at this circuit. From negative electrode, that is cathode, electrons are moving in this direction, but when you indicate the current direction, it is in the opposite direction to that of electron. So the direction of current in a circuit is indicated in the opposite direction of electron. Now let us talk about drift velocity. In absence of electric field, the electrons will be moving in a zigzag manner. That is, it is moving at random directions. So this will result in slow motion of electrons in the conductor in a direction opposite to that of electric field vector that is applied. But the average velocity required by the electrons inside the conductor when we apply the electric field. So the time taken between two successive collisions of electron is called mean free time, that is represented by tau. So an acceleration is experienced by this electron in the presence of electric field. So we know F is equal to E into Q, that is force is equal to electric field into charge, and we also know F is equal to ma. So we can compare the LHS based on that. RHS should be equal, therefore ma is equal to EQ. Let us include the vector. So ma vector is equal to minus E vector into E. Since the acceleration of electrons are in the opposite direction, so the negative sign indicates that opposite direction. And A vector is equal to minus E vector into E divided by M. Now let us come back. A vector is equal to minus E into vector E divided by M, where M is the mass of electron. That is 9.11 into 10 power minus 31 kg. And the drift velocity is equal to Vd vector is equal to A vector into tau. Here tau is the mean free velocity, mean free time, and that is the time taken between two successive collisions. So Vd, that is drift velocity, is equal to, we can substitute this A, and based on that we can work out minus E into E vector divided by tau divided by M. So minus E into E vector divided by M into tau, where E, that is charge of electron, is constant, tau mean free time constant, M mass of electron constant. So we can isolate this and we can call this as mu. So mu is the mobility of electrons. Now substituting this equation, we can get drift velocity is equal to minus u into mu into E vector. And when we introduce the magnitude, so mu, that is the electron mobility, is given by the ratio between the drift velocity, the modulus of drift velocity, and the modulus of electric field. Here we consider only the magnitude and we don't consider the, since we have put magnitude, so I mean modulus, it represents only magnitude. So you can remove the minus sign. Then, now let us consider a problem. Here the electric field is given as 570 Newton per coulomb. A is asked. We know E is equal to 1.6 into 10 power minus 19 coulomb, and the mass of electron is 9.11 into 10 power minus 31 kg. So we already know F is equal to ma, F is equal to E into E, small e, and we can put a Q, but we already know N is equal to, we consider only one electron, so Q is equal to E, E into small capital E, and we can equate this. So E is equal to ma, and we are interested to find out the acceleration. Therefore A is equal to E into capital E divided by M. Now we can substitute all these values and to get acceleration. So the acceleration is 1.001 into 10 power 14 meter per second square. Always practice solving problems by using logarithms. If you do not know logarithm, please go to my video where I explained about the logarithmic problems. Now, Let us move to the next topic, that is microscopic model of current. Let us consider a conductor. Here it is magnified, and let us consider a copper conductor where we have got the cross section A, area of cross section, and we have got the electron whose drift velocity is Vd, and in a shortest interval of time dt, the electron, let us consider one electron, it is moving to a position to cause the displacement dx. So dx is the shortest distance traveled by the electron in dt time, that is shortest interval of time. We can call it the distance element also. Here Vd, the drift velocity, is displacement divided by dt, so dx by dt. Now dx is equal to Vd into dt. You can multiply area on both sides so that you are able to get, that is dV on the left side. Right side you will get A into Vd into dt. So A into dx is nothing but the small volume. Now let us consider number of electrons, okay, E, where this number of electrons divided by, that is dV, can be called the number of electrons per unit volume. So we can come here. Here I have explained, that is we have the, that is dV is equal to A into Vd into dt. Multiply on both sides by n, and then n is equal to, so this is nothing but the total number of electrons, and this dV can be brought here, so divided by dV. So this is the total number of electrons in a given what, the volume. So n is equal to A into Vd into dt, and instead of n by dV you can put n dash also to distinguish the current density per unit volume. Okay, right. Now let us go back. Here this Ne by dB, which is nothing but AV dt, Vd into dt into n. So this n is very, very important, which represents the number of electrons in unit volume element. That is called electron density per unit volume. Therefore dq is equal to, this is the charge E into this much. Therefore I is equal to dq by dt, and dq by dt, that is dt can be brought here. So dq by dt is equal to E into A into Vd into n dash, or you can put n or n dash. Therefore I is equal to Ea into Vd into n or n dash. You must remember this n dash is nothing but current density per unit volume. Do not forget that. Next, let us talk about the current density. Current density is given as I divided by A. So I is equal to NEAVD and divided by A. You can bring this A to the denominator of LHS, so that J is equal to N dash E into Vd. So this is called the current density. And we know already Vd is equal to this much, and current density is given. Then sigma is nothing but conductivity. So this N is a constant, E is a charge, tau mean free time, m mass. All these things can be brought as arbitrary constant, and that is sigma. Therefore J vector is equal to, you got this minus into sigma into vector E, that is the electric field. Therefore sigma in this case, it represents the conductivity, and J vector is equal to minus sigma into E vector, that gives the Ohm's law. So this is known as microscopic Ohm's law. Rho is equal to the reciprocal of sigma, and this rho is nothing but resistivity. Sigma we already know, conductivity. So we can have these two equations for this. And let us consider a problem. Area of cross section of a conductor made up of copper is given as 0.5 millimeter square. I is equal to 0.2 ampere, and the current density per unit volume is given as 8.4 into 10 power 28 per cubic meter. You must remember that this n dash, it is not simply n, it is the electron density, that is number of electron per unit volume, and that is why they are given this unit per cubic meter, right? And based on this n dash, you already know, so dx is equal to v into dt. I think I already discussed about all these things. So from this equation you can find out the a also, the dv also. Okay, so the final equation is, that is n is equal to a into vd into dt into n dash. So all are given. You have to find out the drift velocity by rearranging and substituting these values. So you can get me the answer for this question in the comment column. Thank you very much for watching this video.